Okay, now let's look at our last example for our Metasploit basics, and then we can move on to actually penetration testing our targets. So we want to use a tool called MSF Venom. We're going to build a standalone payload in this example. So MSF Venom is an encapsulation of two different Metasploit tools. If we go to user share Metasploit-framework again, you can see our Metasploit tools, like here's MSF update, MSF console, MSF CLI, so here's MSF Venom, and we also see MSF payload and MSF encode. So MSF payload builds a standalone payload, so we can use the Metasploit payload system to make various kinds of payloads, like we can make executables, we can make raw shellcode to drop into an exploit, which we'll do in exploit development, and then we can run it through MSF encode. So MSF encode will, as the name implies, encode the payload. So it will use various encoders. We saw one, Shikata already, and it will encode the payload, get rid of any bad characters, and prepend a decoder so it can decode itself back into its original form once it's in memory and it's being executed. So MSF Venom that we're going to use just encapsulates those two tools into one, so we can just use one tool. If you've used MSF payload and MSF encode before, you can continue to use them if that's what you're familiar with, but I'm going to use MSF Venom. Alright, so we can do MSF Venom-H for help. And that will show us our help momentarily. Here we go. So we're not going to use all of these here. We're going to see MSF Venom a few times in this class. We will use it for making shellcode and exploit development, and we will use it a few other times. It may be helpful in our pen test. We may find some places we might want to upload something, for instance, and we may also use it during avoiding antivirus. So a few different times it'll come up. Space and bad characters, for instance, we'll use those during exploit development. We need to fit in a certain amount of space in memory, and there'll be bad characters we need to avoid based on what protocol we're talking to. Those may vary. We can set a specific encoder, like that Shikata encoder. We don't need that here. We're just going to do a very simple example of making a malicious executable. Kind of ran off the screen here. At the top we have -P for the payload. So we can set a specific payload. We can also list out the payloads with -L. And there's some other options as well, like -O will show us the options. -X we can actually put it inside of another executable. So we can put our payload inside of an executable. Use it along with this -K option, which will put the payload in a separate thread. So if the user runs this executable, it'll look like the original one. It'll still function normally, but it'll have this extra functionality of our payload. So it'll be useful for making a Trojan. So we may see that later on. Alright, so let's do, for our example, I want to set the payload as Windows Meterpreter reverse TCP. So that is the default payload for most of our Windows exploits. So if you don't set a payload on a Windows exploit, this is probably what you'll get. So we want -P Windows/Meterpreter/reverse_TCP. Again, Meterpreter is Metasploit's special payload, so it has additional functionality on top of just a regular command shell. We will use it extensively in this class, but we haven't really seen it yet. We need -O for the options. Again, we haven't seen this one, so we're not sure what the options are going to be. Give it a second to load. Just going to have to ask on the fly. Alright, so usual suspects for reverse payload, lhost and lport. We need to tell it who to call back to. And like MSF CLI, we want to specify our options like this. So we would say lhost equals, and then the IP address of Kali. You can use an ipconfig to find out if you need to. Make sure your IP addresses are correct. If they are not, then we will have some problems. So lhost equals IP address of Kali, and you can also change lport as well from the default 4444. Any available port will work. So now we need the format, so that's going to be -F if we come back up here. -F for format. And it says we can do a --help-formats. to find out what our available formats are. So --help-formats. It'll show us all the available formats. So we want to make an executable here. We have some other options as well, like ELF, DLL, ASP, VBA, PowerShell, WAR. And we also can have it put out raw shellcode in forms that work with the syntax of various programming languages. When we do exploit development, we'll be working with Python. So we'll use this Python format for our shellcode. But for now, we just want exe. So -f for format. And exe, we don't need to set any bad characters or specify any space or specify an encoder here. We basically just want to make an executable that when the user runs it, just runs this Windows Meterpreter reverse TCP payload. So there won't be any graphical user interface. It'll just send a shell back to us with the reverse connection. And it will be Meterpreter. Alright, so let's put it into a file. I'll just call it meterpreter.exe. We do need to put it in a file. If we don't, it'll just write it to the screen, which is useful for shellcode, but not very useful for executables. So it will generate this payload and put it in meterpreter.exe. It will take just a minute to finish. And it complains that we didn't set a platform, but it grabs Windows from the payload. Same way with the architecture, it just grabs x86, and it doesn't have any encoders, but it doesn't need an encoder, so it doesn't matter. So what I want to do is copy this file to var www. That is the default location where the Apache web server serves pages from. So that just copies that file there. We do need to make sure the Apache web server is started. It does not start up by default when you turn on Kali. So we would do service Apache 2 and then start. Mine's already running. Yours may not be. So then if we come over to XP, in this case, we're just going to download the file. We're going to play the user. So we will, when we do social engineering, look at other ways of getting a user to run something on our behalf. So let's not run it just yet. We actually need to do something on the Kali side first. So far, when we've run our exploits either in MSF console or MSF CLI, actually the first thing it does after we type exploit, or big E in the case of MSF CLI, is it sets up a payload handler based on whatever payload we chose. So we've tried a bind shell and a reverse shell, so it sets up different handlers based on what payload we choose. But here with MSF Venom, we're not going to have a payload handler set up automatically. So if we just go ahead and run that on the XP system, it'll run just fine. There's nothing to catch it. Over here on the Kali side, there's no port listening for a Meterpreter connection. So we can't just use netcat like we did during our Linux section, because netcat's not going to know how to finish the staged payload, as well as it's not going to know how to speak Meterpreter. So we are actually going to have to use Metasploit. So let's start up MSF console, and we're going to use a special module called multi/handler that is specifically designed to deal with this particular problem of catching incoming payloads that need a handler that were launched outside of the framework. So in this case, we used MSF Venom to create a standalone executable, and we just need a handler to deal with its payload. So multi-handler will be ideal for that. So as usual, MSF console takes a little while to start. If you add more memory to your VM, it will be a bit faster. So if you have that resource available, I encourage you to take advantage of it. So you won't have to sit here like me. There we go. So different ASCII art this time. If we do an info on multi/handler, its full name is exploit/multi/handler. But we can drop off the first part as usual. So this module is a stub that provides all the features of the Metasploit payload system to exploits that have been launched outside of the framework. That's exactly what we need. Some way to handle our payload. So let's use multi/handler. Now we're in the context of that handler. So if we show our options, basically it says nothing. So what we need to do is actually tell it what payload we want to handle. The handler will be different based on what payload we want. So in our case, we want Windows interpreter reverse underscore TCP. So we want it to come out exactly the same as what we set in MSF Venom. So now if we do show options, we see our options for interpreter reverse TCP. So again, we need to set our options, and again in MSF console we say set option to set, and then what we want to set it to. So now option equals, like we do in MSF CLI or MSF Venom. We need to set the IP address of Kali here, and you can run ifconfig right inside of MSF console. We don't have to exit out. We can exec commands right inside of MSF console. We can set lhost IP address of Kali, and we did set lport to 1234. That's always the one I use for some reason for my examples. We do need to set it to the same port here, otherwise our handler will be listening on the wrong port. Windows XP will call back to port 44, or it'll call back to 1234, and we would be listening by default on 4444, so we wouldn't actually catch the incoming interpreter session. We do need to set it the same way, and then we can say exploit. So we don't automatically get a session here like we did with our exploits, where this time we're not dependent on any exploit at all. It's just a payload. So we're instead expecting the user to run it for us, so we don't need any particular vulnerability. When we get into client sides and social engineering, we'll see a lot more of this, that in some cases, even if a system is fully patched, we just ask the user, hey, can you exploit yourself for me? And unfortunately, more often than not, that'll actually work without too much trouble. So we'll see more of that a bit later on. Just kind of play the user in this case, and just come over here and click run. It's not signed. We could, of course, sign it. But let's be realistic. When has this ever stopped anybody from running anything? We go ahead and click run. And again, there's no GUI over here. It doesn't actually do anything. Besides run the payload, we could use that -x and -k option in MSF Venom, which we will do later on to make a Trojan, so it does actually do something on the Windows side. We did get a interpreter session here. If we come back to MSF console on Kali, so we can say help, get our basic commands. We are systems. If I do get UID, actually we're not a system. I lied. With our MS 08067, we were a system because we exploited the SMB server. Who are we instead? We are the user Georgia. I'm currently logged in as the user Georgia over here, so that makes sense. Georgia started this process, so it's not system at all. We are in fact a user. We are an administrative user, so we may have ways we could perhaps easily become system. See, like our hash dump option, so we could try that. Maybe get some password hashes. So that was easy. And we have things like we can do key logging, or take a picture, a screenshot. We can drop into a shell. I encourage you to spend some time with Meterpreter. We will use various Meterpreter commands. We just basically have the basics here. There are some other Meterpreter commands we can use. We can load additional extensions for our Meterpreter. We can run post modules on it. We can run Meterpreter scripts. We'll do all of that when we get into post-exploitation. But again, I encourage you to spend some time in Meterpreter now if you want to, before you go on to the next videos. It's pretty cool just to play with, and I encourage you to deviate from what I do. I'm just going to show a few examples of various things as we go through the course, so there'll be lots more you can do on your own, and I encourage you to do so to get the most out of this class. So that's all we're going to do for our basics of using Metasploit. And we will come back to Metasploit over and over throughout the class, so I just wanted to get the basics down, and you can come back to these videos so we don't have to keep going over the basics every time, because we will use it pretty much in every module in the entire class. So now let's actually get started pen testing.